All right, number 11. So this is one of those ones where it's very contrived, but this is one of the few that we're actually going to be able to do the antiderivatives. So let's go ahead. It's already in the form y equals, so let's go ahead and find out what dy dx is. It's going to be 1/3 times, bring that power down, 3/2 times, keep the inside the same, reduce the power by 1, and multiply it by the chain rule. And lo and behold, these 3's cancel, these 2's cancel, and it leaves us x times x squared plus 2 to the 1/2. So far so good? Great. Now let's go ahead and let's do the integral for arc length. So I'm going to start a new chain of equal signs. The arc length is going to go from, is going to be the integral from 0 to 3 of the square root of 1 plus x squared plus 2 to the 1/2, and all of that is squared dx. I don't think I've made a mistake yet, but be patient, it's coming. Now someday I'm going to do a class and I'm only going to speak highly of myself. And I don't know what it's going to be like when it's coming. Not today, Ann. Alright, so let's go ahead and let's see if we can clean this up at all. We still have a square root. We still have a 1. When we square this, we're going to get an x squared. When we square this, though, the squared and the 1/2 power are going to cancel, leaving us x squared plus 2. And this is all still dx. Integral from 0 to 3, once again, square root of 1. Let's distribute this through, and we get x to the 4th. Distribute that through, and we get 2x squared dx. And then coming down here to continue this chain of equal signs, with every single step being equal to the previous step, we are going to realize that the thing under the square root is in itself a perfect square. I rewrite this, and we see that the thing under the square root is the square of x squared plus 1. Shock and amazement. So the square root of a square is just the stuff underneath there. And then we're ready to do the antiderivative. The antiderivative of x squared is 1/3 x cubed. The antiderivative of 1 is x. And then we're going to evaluate these on the interval from 0 to 3. We end up with 1/3 3 cubed plus 3. And we're going to subtract that by 1/3 times 0 cubed plus 0. And like happens so many times, that ends up just being a big fat 0. We don't worry about it. And we've got 3 cubed, which is 27 divided by 3, which is 9 plus 3 plus 3, which is equal to 12. So and that happens to be the answer. What's that? So heavily contrived so that we get out of that nasty square root something that's actually integratable. All right, there's number 11.